All right, this video is going to cover notes from section 6.1, which deals with rational functions and equations. We'll start with number one, where we're asked to find the domain. Now, remember that domain is all of your x coordinates. So you want to know what are the possible coordinates that could be used for x. For this to be a rational function, the denominator cannot equal 0. So to find the domain, you take this denominator and you set it equal to 0. In this case, our denominator is x plus 1. We'll set it equal to 0 and we solve the equation. Subtract 1 from both sides of this equation. The 1's will cancel on the left, and we'll have x equals 0 minus 1 or negative 1. So when x is negative 1, our denominator is 0. Therefore, the domain could be any number for x except for negative 1. It can't be negative 1. Therefore, the way we would describe this domain is by putting the limitations, part A, in set builder form. So we want values of x such that, remember this vertical line means such that x cannot be equal to negative 1. And using interval notation for part B, we'd write, you can draw a graph just to see what that image looks like. We have an open circle at negative 1, meaning that the value of x cannot be negative 1, but it could be any number that's less than negative 1 or any number that's greater than negative 1. We'd write this interval using parentheses. On the left, we have negative infinity, comma, negative 1. And the union, this will be or. On the right side, we have parentheses again, negative 1 comma positive infinity. So this would be interval notation. Let's look at the next example. We're going to look at this graph, and we see lines on the left side, on the right side, and we want to suppose that this is the graph of the function y equals f of x. Letter A, find f of negative 2. So f of negative 2, when we are at negative 2 on the x-axis, our function, neither of the graphs touch this point. Therefore, this function does not exist at negative 2. It's undefined. Part B, find f of 3. Where is our graph when we're at 3 on the x-axis? This is 3 on the x-axis. Our graph is right here crossing the origin. So this point, f of 3 is going to be 0. Letter C, state the equation of the vertical asymptote. Asymptote is the point where the graph does not cross, and that's this point right here at 2, this vertical line that's cutting through negative 2. It's dotted, and we'd write that equation as x equals negative 2. It's the vertical line that cuts through the x-axis at negative 2. All right, let's look at the next example. We have f of x equals x minus 4 divided by 3x plus 2. Find f of negative 3. To find f of negative 3, we're going to substitute negative 3 everywhere we see x. So this will become negative 3 minus 4 in the numerator. That simplifies to negative 7. In the denominator, 3 times negative 3 gives us negative 9 plus 2. And we'll simplify more. In the denominator, negative 9 plus 2 gives us negative 7. We carry over our negative 7 from the numerator, and negative 7 divided by negative 7 is 1. Part B, we're finding f of 0, so we'll perform similar steps, except for this time we're going to substitute 0 everywhere we see x. So f of 0 is equal to 0 minus 4 in the numerator. That simplifies to negative 4. In the denominator, 3 times 0, that's just 0, plus 2 gives us 2 in the denominator. And negative 4 divided by 2 gives us negative 2. And now f of negative 2/3, we're substituting negative 2/3 for x. In our numerator, we have negative 2/3 minus 4. In the denominator, we have 3 times negative 2/3. That's negative 9, well, negative 6/3. Negative 6/3. That's numerator times numerator. And negative 6/3 is going to simplify to negative 2. Negative 2 plus the 2 makes this 0 in the denominator. And remember, we can't have 0 in the denominator. Therefore, this function is undefined. When x is negative 2/3, the function is not defined. Part D, state the domain using set builder notation. Remember, the domain is when your denominator, we find our limitations based on when our denominator is equal to 0. And we actually just found that when we solved the problem for letter C. Remember, our x coordinate could not be negative 2/3 because when it was negative 2/3, it was equal to 0. So this made this function undefined. Therefore, x could be any other number except for negative 2/3. We write that set builder notation as x values such that x is not equal to negative 2/3. It could be any other number except for negative 2/3. Now let's consider the next function. We have f of x equals 5 divided by x squared minus 3x. Is f of x a linear function? That would be no. Remember, linear functions can be written in that slope-intercept form, that y equals mx plus b form. And we see here that we have x squared in the denominator. So this would not be a line, the graph of a line, and therefore not a linear function. Part B, find f of negative 2. So in our original function, we're going to substitute negative 2 everywhere we see x. F of negative 2 is equal to 5 in the numerator. We'll keep the 5 in the numerator. And in the denominator, negative 2 squared, that's positive 4, minus 3 times negative 2, that's positive 6. So 4 plus 6 in the denominator, that simplifies to 10. 5 divided by 10 reduces to 1/2. Letter C, state the domain of f of x. The domain of this function, we want to know the limitation. So we have to set this denominator equal to 0. So x squared minus 3x, we set that equal to 0. And we want to solve this equation. But we have a GCF that we can factor out first. We can factor x from x squared. That leaves us with x in parentheses. When we factor x from minus 3x, that leaves us with minus 3 in parentheses. Now we're going to set each of these factors equal to 0 and solve the equations. So that first factor outside x equals 0. That's one of our solutions. And then the second we'll get by setting that second factor, x minus 3, equal to 0 and solving the equation. We're going to add 3 to both sides of this equation. The 3's cancel on the left side, leaving x. And on the right side, 0 plus 3 gives us 3. So our two solutions are 0 or 3. Now, when x is 0 and when x is 3, our denominator becomes 0. So the limitations we write in set builder notation would be x values such that x is not equal to 0 or 3. Next, we're going to solve the rational equations and check our work. You solve rational equations by cross multiplying. Remember, you're just going to multiply the terms that are diagonal to each other. Now, originally we had 8 over x equals 5. You want to make that 5 a fraction by putting it over 1. And then we're going to cross multiply. So 8 times 1 gives us 8. Carry down your equal sign, and then the opposite product. X times 5 gives us 5x. We would solve this equation by dividing both sides of the equation by 5. The 5's are going to cancel on the right side, leaving x, and we have x equals 8/5. So we're done. Now the way that you can check your work is you would just substitute 8/5 for x. in your original equation. So 8 divided by x, instead of 8 divided by x, 8 divided by 8/5. And we want to know if this is equal to 5, and it is. Because remember, dividing by a fraction is the same as multiplying by its reciprocal. So we take the reciprocal of that 5/8 and multiply. So we would get this. We plug it into our calculator, however you want to solve to divide, but you should get 5 if you do that correctly. The 8s are going to cancel, and you're left with 5. Our next problem, we have x divided by x plus 16 minus 3 equals 2. So we want our 3 to be combined with a 2, so we're going to add 3 to both sides of the equation. We want this to be in that form of the previous problem. We have the fraction by itself on one side of the equal sign. The 3's are going to cancel on the left side, and we're left with x divided by x plus 16. On the right side, we have 2 plus 3, that gives us 5. And we write that 5 as a fraction by putting 5 over 1, and then we're going to cross multiply. So we multiply 1 times x, that gives us x. Carry down your equal sign, and then the opposite product. 5 times x plus 16. We keep the x plus 16 in parentheses so we'll remember to distribute that 5. On the right side of this equation, 5 times x gives us 5x, and 5 times 16 gives us 80. Carry down your x. We're going to solve this equation first by combining these like terms. So let's leave the 80 here. Let's subtract 5x from both sides of this equation. The 5x is going to cancel on the right side. Carry down your 80. And on the left side, x minus 5x gives us negative 4x. Lastly, we're going to divide both sides of this equation by negative 4. The negative 4's are going to cancel, leaving x equals 80 divided by negative 4, or negative 20. This is our solution. X equals negative 20. All right, the next problem, we have 2x plus 1 divided by 3x minus 2, and it equals 1. But we're going to write that 1 as a fraction by placing a division bar and putting that number over 1. And then we're going to cross multiply. So 1 times 2x plus 1 gives us 2x plus 1. Carry down our equal sign. And 1 times 3x minus 2 gives us 3x minus 2 on the opposite side. Combine like terms here. So we're going to subtract 3x from both sides of this equation, and we're going to subtract 1 from both sides of this equation. The 1's are going to cancel on the left side, leaving 2x minus 3x, or negative 1x. Let's put that 1 there so we'll remember to get rid of that negative sign. The 3x will cancel on the right side of the equation, and negative 2 minus 1 gives us negative 3. Lastly, we're going to divide both sides of this equation by negative 1. The negative 1's cancel. We have x equals 3. Negative 3 divided by negative 1. Now in the next example, we have x divided by x plus 1 equals 2x plus 1 divided by x plus 1. So in this example, we can still cross multiply if we like. But what we want to do in this example is approach it in a different manner. What you notice in this example is that your denominators are alike. So you're saying that some term divided by x plus 1 equals another term divided by x plus 1. So if these denominators are equivalent, then guess what? The numerators must also be equivalent. So we'll just take the numerators and set them equal to each other and solve the equation. So x, the numerator of our first term, equals the numerator of our second term, 2x plus 1. We'll combine like terms by subtracting 2x from both sides of this equation. And when we do that, 2x will cancel on the right side, leaving 1. And on the left side, x minus 2x will give us negative 1x. We'll divide both sides of the equation by negative 1, and we'll get x equals negative 1. Now, when we get x equals -1, what you notice, look at your denominator of x plus 1. X cannot be -1 because if x were -1, -1 plus 1 would make this equal to 0, and we can't have denominators of 0. Therefore, this has no solution. The solution would be the empty set because our value cannot be -1. So we would write no solution because if we were to put -1 in that denominator for x, that denominator would equal 0. All right, let's look at the next example. We have 4 divided by x minus 3 equals x, and we want to make that x a fraction by putting it over 1. We would solve by cross multiplying. So we're multiplying 4 times 1, that gives us 4, carry down your equal sign, and x times x minus 3. We keep the x minus 3 in parentheses so we'll remember to distribute on that right side of this equation. X times x gives us x squared, and x times minus 3 gives us -3x. Now we're going to carry this 4 over to the right side of the equation. We'll subtract 4 from both sides of the equation. The 4's will cancel on that left side, leaving 0 equals x squared minus 3x minus 4. Now we're going to factor this trinomial. X squared we factor using x and x. Minus 4 we factor using -4 and +1. And next we're going to set each of these factors equal to 0 and solve. So x minus 4 equals 0 and x plus 1 equals 0. The equation on the left we're going to solve by adding 4 to both sides of the equation. We'll get x equals 4, or that equation on the right side we're going to solve by subtracting 1. So x equals 4 or -1. And in the next example, we want to solve the rational equation. We have 5x divided by 43x plus 18 equals 1 over x. So we're cross multiplying here. 5x times x gives us 5x squared, and 43x plus 18 times 1 gives us 43x plus 18. We're combining all our like terms, well, combining our terms on the left side of this equation. So we're going to subtract 43x and subtract 18 from both sides of this equation. And when we do that, we'll get on the left side 5x squared minus 43x minus 18 equals 0. We're going to factor this trinomial, factor that 5x squared using 5x and x. And we're factoring the minus 18 using +2 and -9. We'll set each of these factors equal to 0 and solve the equations. So 5x plus 2 we set equal to 0. We're going to solve by subtracting 2 from both sides of the equation and then dividing both sides of the equation by 5. So we'll get x equals -2/5, or that second factor, x minus 9 equals 0, we're going to add 9 to both sides of the equation, and we'll get x equals 9. There are two solutions, -2/5 or 9. And we'll stop here. That's the last example from this section.